So here we've got some law of sines problems that are a little bit more involved. So again, we've got the side-side angle, two consecutive sides in the non-included angle presentation. So this is an example of the ambiguous case, but what we see here is that side B is much larger than side A, so that means that angle B has to be larger than angle A. So one thing we did talk about in class is that the first thing we should do is always think about what is H. We want to find H first. So let's draw what we've got. So we've got angle A, which is 30 degrees. We do not know how long the base is on the bottom, but we do know that this is side B, and it is 40. So that means that angle B over here definitely be larger than angle A. So we do know that side A, it's the swinging side. It's 10. So let's take just a moment and let's find out, well, what is the height? What would be the height in this scenario? So the sine of 30 equals H over 40. So when we find this, turn that on, and let's cross multiply here, 40 times the sine of 30. Remember, you need to be in degree mode. We find that the height is 20. If the height is 20, so if H equals 20, and if H is greater than A, is it ever even going to be possible for this swinging side that's 10 units long to ever close this triangle? No. So with this given information, there are no possible solutions here. So this is what's key to remember right here, that when you find H, if H is greater than the short side A, we do not have the possibility of ever closing this polygon. Therefore, it cannot be a triangle. Therefore, there are no solutions. Let's look at the next problem that's given, which little a is 30, little b is 40, and angle A is 20. So similar situation again. We see that little b is larger than little a. Therefore, we know that angle B has to be larger than angle A. Angle A is 20. So we're going to start the same way that we did on the last one. Here's A, it's 20. This is side B, this is 40. Let's start by finding out what H is in this situation, and that will give us some wisdom as to what A can possibly be, knowing that if A is 30, our H has to be less than 30. So the sine of 20 equals H over 40. Cross multiply, and we find out the length of the altitude here. So 40 times sine 20, that is 13.7. So 13.7. So, all right, we have a situation where A is greater than H. And when A is greater than H, we are looking for two possible solutions. One will be where angle B is an acute angle, and the other solution will have angle B be an obtuse angle. So let's redraw this, and we're going to find that out. So first of all, let's have our acute possibility right here. So once again, we've got, basically it's kind of looking something like that. So angle A is 20, little a is 30. Here's little b, which is 40. This is A, this is B, this is C. So in this case, we've got angle B, which is acute. So let's find the missing parts of our acute triangle here. So we're going to set up our law of sines with our given angle A and our given little a, side A. So 30 over sine of 20 equals, and we are trying to find angle B this time, so use little b, 40 over sine B. So remember, if we're missing an angle, we're going to have to utilize an inverse function in order to do that. So let's cross multiply. 30 sine B equals 40 times sine 20. Divide by 30, divide by 30. Sine B equals 40 over 30 times sine 20. So let's go to our calculator. Remember, we need to be in degree mode. And since I'm taking an inverse, I will utilize my fraction function here. So 40 times sine 20 over 30 gives me angle B is 27.13. Remember, this is our acute version. We're going to utilize this again in our obtuse version in just a moment. So there's our angle B. Okay, so now we got angle B. Now we need to deal with angle C and side C. So let's squish it over here on the side of the paper. Once again, using that given ratio, 30 over sine 20 equals, first, we need to find our angle C using interior angle of a triangle. So 20 plus 27.13, and then subtract that from 180. We need that right over here. So our missing angle C is 132.87. So we're going to have C over sine of 132.87. Squish it on the paper right there. Cross multiply, solve for C. 30 times the sine of 132.87 is, and we will divide that by the sine of 20. So little c is 64.32. So we've got everything here. Angle A, side A. Angle B, side B. Angle C, and side C, 64.32. We just solved for all the parts of the acute version of this triangle. I'm going to keep going, and we're going to find the obtuse version of this triangle. So in the acute version, the swinging side swings out into the exterior. For the obtuse version, the swinging side will swing in, and it's going to look a little bit different. But it's still going to have the same given information. Little a is 30, little b is 40, and angle A is 20. So we saw the acute, now we're going to have the obtuse. We're still going to have this 20-degree angle there. But now that swinging side is going to be coming in. This is still angle A. This is little b, which is 40. This is little a, which is 30. And there we go. That's everything we know. Now, let's use this information. So like we talked about in class, if I were to rewrite all of this again, I'm going to get the same result. But remember, we're now going to use this 2713.13 as the reference angle. So it's supplement 180 minus 27.13. We find our obtuse angle B to be 152.87. So angle B in the obtuse version, 152.87. So now let's finish this off with angle B being obtuse. So once again, if we know angle A, we know angle B, we can use triangle interior angle sum theorem, and we can find angle C. So 20 plus 152.87, take that away from 180, we find angle C to be little tiny 7.13 degrees. So now we've got A, we got B, we got C. We know little a, we know little b. All that's left is to find little c. Let's set up the law of sines and let's use it. Remember, this was the given ratio from the given information in the law of sines. So let's utilize that. So that's going to be 30 over the sine of 20 equals little c over the sine of our new c, 7.13. So cross multiply and solve for c. So here we go. 30 times the sine of 7.13 divided by sine of 20. Little c is approximately 10.89. So we got everything. Angle A is 20, side A is 30. Angle B is 152.87, side B is 40. Angle C is 7.13, and side C is 10.89. We have solved the entire triangle.